Percent. What percent of diagonal line is outside the inscribed circle? Now that's an interesting question. We are not given any dimensions in this question, but we need to figure out percent. Well, the beauty is percent is kind of a ratio, and here we really don't need any dimensions. So what we will do here is we'll just write some variables, right? So if this is a circle, that means its diameter is going to be constant, right? So that means the diameters are same. That means the outside figure is a square, right? So let us assume that the square has length of d and width of d, right? So that is what becomes a square for us. Now we need to find percent of diagonal line which is outside the circle inscribed within a square. So that is the question. Now the line which is outside is this part of the line. You see, this part of the line is outside the circle inscribed within the square. So we need to find that percent. Now percent is change over the original length. So first thing is we should find the length of the diagonal. So what is the length of the diagonal? Now to find the length of the diagonal, we can use Pythagorean theorem. We know this is a square, and so these are at right angles. So we have a right angle triangle here whose sides are D and D. So let's find what is the length of the hypotenuse, right? So the length of the line is how much? Let us say it is L. In that case, we know using Pythagorean theorem, L square is equals to d square plus d square, right? So which is 2 times d square. So what is length? L equals to? L equals to square root of 2 times d square. That gives us d square root of 2, right? So that becomes the length. Now it says what percent of diagonal line is outside the inscribed circle. Now we know the diameter is d, therefore inside is d. The outside length will be total length minus d. So outside length equals to total length minus diameter. So that is d square root 2 take away diameter. So that is the total length. We can take d common and write this as square root of 2 minus 1, right? So that much of length is outside the circle. Now we need to find percent. So percent of length outside is equal to the outside length divided by total length times 100, right? So it is d times square root of 2 minus 1. This is the outside length over total length, which is d times square root 2 times 100. Do you see that? Now here d and d, the diameter which we assume to be d, cancels out. So that shows that whatever value we take here, it works, correct? You could have taken just the number 1, for example. That could have simplified our solution by a large extent. Do you see that? 1 could have worked far better than d, right? Anyway, now we have square root of 2 minus 1 divided by square root 2 times 100 as our answer. Let's use the calculator and figure it out. So we have square root of 2 minus 1 divided by square root of 2 times 100, right? What do we get? We get 29.289. 29.289, which we can approximate to around 29.3%, right? So that is how we can calculate. Now, my suggestion is, if a question is like this, it is better to assume, as we realized, the length as 1 unit. If I use 1 unit as the length, then my diameter as a whole will be square root of 2, right? You know, square root of 2 is what? 1.414, correct? So diameter is 1 unit and outside length will be 414 minus 1 divided by total length, which is 1.414 times 100. Correct? If you do this, you get the same answer, approximately 29.3%. Right? So the suggestion is that use, instead of a variable d, unit length, and then figure out the answer. I hope that helps. Thank you and all the best.